I am going to explain thin prism formula. Previously, we derived the prism formula, right? And I will give the two methods now to derive that. Thin prism formula I am going to derive. Thin prism means what first? Angle of prism. If angle of prism is less than 5 degree, then such prism is called as thin prism. Thin prism means its angle of prism should be very less. Okay. Thin prism formula I am going to derive. Previously, okay, we derived refractive index of prism formula. It is very important. Right? If angle of prism is less than 5 degree, then the prism is called as thin prism. Now let us see here. If angle of prism is very less, at that moment, the refractive index of prism formula we know that refractive index of prism. What we write? Refractive index of prism according to Snell's law. From the basic formula we write like this. This is a prism and this angle is angle of prism. It should be less than 5 degree. Then it is called as thin prism. Now see this thin prism. Its refractive index I want, and one light ray it is incident at here at an angle of incidence I1, and it will be refracts and it will be travel like this, and then it will goes outside like this. And we have the formula for the refractive index of the prism, that is nu is equal to sine I1 by sine R1, or we may write nu is equal to sine I2 by sine R2. This is the formula. And but in case of small angles, in case of small angles, we write sine theta as theta only, sine 0 0. Then according to that, the equations will be changes like this. Nu is equal to I1 by R1 we write. From this, if you write the I1 formula, we will get a new R1. This is equation 1 we can consider. And the nu is equal to, we know, sine I2 by R2. And from that we write sine I2 by R2. Sine we write as sine I2 we write as I2. Sine R2 we write as R2. Then from that we will get I2 formula. I2 is nu R2. This we can consider as equation 2. And then we know already from the prism derivation, that is I1 plus I2 is equal to A plus D. This we know. And one more formula we know, R1 plus R2 is equal to A. From this, here we substitute the I1 value and I2 value. Before that, I want the deviation angle at here. Right? What is the deviation angle? Deviation angle is D is equal, we write as I1 plus I2 minus A. Okay. Then in this we substitute the values. Okay. I1 is what? Nu R1 from equation 1. And I2 is nu R2 from equation 2 minus A. This is from equation 1 and 2 we write like this. Here we can common the nu at here. Then we will get R1 plus R2. But in the previous derivation, during the prism formula derivation, we know that R1 plus R2 is A, right? r1 plus r2 is equal to, we know as a. Then this we substitute it here, then we will get nu a minus a. Then we will get as nu minus 1 into a. This is called as, this is the formula for deviation angle. Deviation angle in thin prism, and simply it is also said to be thin prism formula. Okay, right. And now I'm going to continue. If you have any doubt, you can ask me. Take the screenshot. You note some important formulas regarding the prism, right? What we know the prism formulas. That is the first one you remember. This is I1 plus I2 as A plus B. The second one you remember as R1 plus R2 as A. Okay, from this we write, from this equation we write also D formula. I1 plus I2 minus A. And this is equation 1, and this is equation 2. And the refractive index of prism. Okay, minimum deviation condition we write. Minimum deviation condition. Minimum deviation condition is what? The minimum deviation condition? I1 should equal to I2 and R1 should equal to R2. Then we will get deviation angle as delta, that is minimum. Okay, and this is the condition for the minimum deviation. If you substitute these conditions, then we will get I and A as I is A plus delta by 2 from equation 1. From this you see here I1 plus I2 is A plus delta B, and from this if you substitute these conditions, then we will get I1 is I and I2 is, you see here cursor equation, I1 plus I2 is A plus D. In this we write I1 is I2 or I2 is I1, then D is delta, then we will get I1 formula. Okay, and here let us consider, we already derived that one. And now from this refractive index of prism, refractive index of prism at minimum deviation, right? At minimum deviation. Now the refractive index of prism formula is, here we don't no need to write the minimum deviation. Refractive index of prism formula is nu is equal to sine I1 by R1 we write, or sine I2 by R2 we write. Or otherwise, if you find out the I1 and R2 from equation 1 and 2, we will get formula is sine of A plus delta by 2 by sine A by 2 we will get. What is delta at here? Delta is the minimum deviation angle. A is the angle of prism. Okay. Right. What is delta in this? Delta is the minimum deviation angle. Minimum deviation angle. These formulas you must remember. Okay. This formula and this formula and this formula you must remember. Okay. This is the note point what you should remember. And the next continuation, let us see here. And the continuation, two cases I am going to explain, and you listen very carefully. Okay, right. The first case is that normal incidence and grazing emergence. Normal incidence and grazing emergence. Grazing emergence. What is this? Normal incidence and grazing emergence. Normal incidence and grazing emergence means this is a prism. This is a prism. And now the light ray is incidenting along the normal. Light ray is incidenting along the normal. Like this it is incident. That means this is only normal and this is only incident light ray. And grazing emergence means it will go after the refraction along the surface. This is called as the grazing emergence. If you draw the normal at the second surface, this is the normal drawn. And that means light ray is going along the surface, that's why emergent angle will become I to I is 90 degree. When one angle is 90 degree, that other angle must be equal to C. And here this is the, you see the incident light ray, that is a red line. You see the cursor in the diagram. Incident light ray is, the light ray is incidenting along the normal. It is only incident light ray, that is only normal. That's why angle of incidence at this point becomes 0. I1 is 0. When I1 is 0, automatically from the Snell's law R1 is 0. Here angle of refraction will be there. But here angle of emergence is 90 degree. That's why R2 should be equal to C. Right? Now let us write some conditions from the figure. That is the normal incidence. We write angle of incidence as 0. Okay, what we write here? We write some points. Angle of incidence as 0 we write. Okay. And one more thing, when angle of incidence is 0, automatically angle of refraction is 0. Second point is that angle of emergence is 90 degree. One angle of emergence is 90 means that the angle of refraction at the second surface, it should be equal to critical angle. Because at the critical angle only emergent angle become 90 degree. That's why this will become C. What is C here? C is the critical angle. Critical angle. Okay. Now the second next one is, write the third point right here. Deviation angle. In this case, what happens? Deviation angle. The deviation angle formula is I1 plus I2 minus A. We write as I1 is 0, I2 is 90, A. Then we will get the deviation angle as 90 minus A. And one more point, I will write the refractive index of prism. Refractive index of prism formula we know. Nu is equal to, we write as sin I1 by sin R1 we write. Or sin I2 by sin R2 you write. Any one formula we can use. But here I1 R1 are 0, that's why we cannot use that formula. And then we use sin I2 by sin R2. What is sin I2? Okay, sin I2 we write as 90 and sin R2 we write as C. We write nu is equal to 1 by sin C. Nu is equal to, we write as 1 by sin C. And one more point we write, we know R1 plus R2 is equal to A. Yes. Then from that R1 is 0, then R2 is C, then A. Then we write A is equal to C. A is equal to C. Then here, if you write substitute in place of C as A, then we will also get 1 by sin A also. This is from fifth point we are getting. Okay. This is the normal incidence and grazing emergence. Let us discuss one more case, and you take the screenshot and note it. I'm going to rub some points in the left side and I will write. You see here, now I am going to explain the grazing incidence and grazing emergence. Let us see here, this is a prism. In the normal cases, this angle we take as angle of incidence, angle of prism. This is the ABC, is the prism. What happening it here, light ray is grazing incidence, means along the surface the light ray is incidenting. Light ray is incidenting along the surface, like this. Okay, after the refraction, after the refraction, this is the normal drawn it here. This is the normal. And here angle of incidence will become 90 degree because light ray is incidenting along the surface. If the light ray incident along the surface, that is called as grazing incidence. You see here the light ray is incidenting along the surface, red line, that is called as grazing incidence, and blue line is the normal drawn, and the angle between the incident light ray and normal drawn is called as angle of incidence. In case of prism, the angle of incidence we consider as I1, that I1 is 90 degree at here. After the refraction, it will go like this. It will bend towards the normal. It will bend, it cannot go in straight, it will bend towards the normal, and the light ray will go like this. And it will incident on the second surface. Let us draw the normal at the second surface. This is the normal at the second surface. Then again the light ray is emerging along the surface only. This is the emergent light ray. Okay. That means the light ray is going along the surface after the refraction. This is the grazing emergence. Okay. Now this is the emergent light rays makes 90 degree with the surface. That's why angle of emergence is also again 90 degree. But when the incident, you see here, when this angle is 90 degree, generally this angle is R1 and this angle is R2, refracting angle. And we wrote this as R1 and this as R2. But one angle is 90 degree means other angle must be equal to critical angle. Here you see here incident angle is 90 degree means refracting angle should be critical angle. If this angle is critical angle, then this angle is 90 degree, right? That means we write the condition set here. The first condition is that angle of incidence is 90 degree because it is a grazing incidence, and angle of incidence is 90 degree, then angle of refraction equal to critical angle. And the second point we write is angle of emergency also 90 degree. Then we write R2 also C. And then the deviation angle we have to write. Okay. Third point we write as deviation angle. What is deviation angle? Formula we know is I1 plus I2 minus I1 plus I2 minus A. We know that equation, that is I1 plus I2 is equal to A plus D. From this deviation angle formula we will get. But I1 is 90 degree. I2 is also 90 degree. And A. Then deviation angle we will get is 180 minus A. But we know one thing that R1 plus R2 is equal to A. One more formula we know. From this R1 we write as C and R2 we write as C. Then we will get 2C is equal to A. From this critical angle is equal to angle of prism by 2. C is equal to A by 2. Fifth point regarding this, we write refractive index of prism. Refractive index of prism. What you write here? Nu is equal to we write as sin I1 by R1 or sin I2 by R2 we write. Anything we can write. And then from this we will get sin 90 by sin C we will get 1 by sin C. Nu is equal to 1 by sin C. But C is A by 2. That's why we write as sin A by 2. From this we write as nu is equal to 1 by sin A by 2 we will get. These are the conditions. Okay. This is about grazing incidents and grazing emergence. Let us discuss some problems. That is the first problem is that for glass prism nu is equal to root 3. Refractive index is root 3. The angle of minimum deviation is equal to the angle of prism. Find the angle of prism. What they give in the question? Refractive index of prism is root 3. We write in solution. First we write the given values. Refractive index of prism root 3. And angle of minimum deviation is equal to the angle of prism. Angle of minimum deviation denoted with delta, right? Angle of minimum deviation denoted with delta, that is equal to angle of prism, that is equal to A. Okay, you note it. A has two names. One is angle of prism. Okay, in some problems they may give it as refracting angle also. Okay, refracting angle. Now the question is that angle of prism is what? We have formula nu is equal to sine of A plus delta by 2 by sine A by 2 we have. Now we substitute all values it here. Nu is root 3. Sine of A plus delta by 2. What is delta? Delta is A again by 2 by sine of A by 2 we write. Now we have to simplify now. If we simplify then we will get root 3 is equal to sine A plus A by 2 is nothing but A only we will get. In the denominator we will get as sine of A by 2. There is the formula is there in the mathematics. That is sine 2 theta we write as 2 sine theta cos theta we write. Or if sine theta is there then we write this as 2 sine theta by 2 cos theta by 2 we write. These are the mathematics formulas. These are the mathematics formulas that we use it here. Sine A we write as 2 sine A by 2 cos A by 2 we have to write according to the second formula. And then here sine A by 2 in the denominator already there. They will be cancelled now. Right? This will cancel. What's remaining in the next step? Root 3 is equal we will get as 2 cos A by 2 will. And now we have to write it here. Cos A by 2 what we write here? Cos A by 2. From this cos a by 2 we will get as root 3 by 2. That means cos of certain angle a by 2 should be equal to cos 30 value is root 3 by 2. Let the right 30 degree. Then a is equal to answer we will get a 60 degree. They are asking to find the value of a. The solution. Let us go for one more problem. They gave the figure in this problem. There is a prism and this angle they gave as 60 degree, and A, B, C is a prism, and BA they gave as refracting surface. You see this BA is the refracting surface, AC is also refracting surface, and this is the angle of prism or the refracting angle. Okay, and this is the 90 degree. Then automatically the A value angle of prism becomes sum of three angles should be equal to 180. 90 plus 60 150. Then A is equal to 30 degree we will get. In the solution we will get angle of prism as 30 degree. And the refractive index of the prism they give as 1.5. Okay. And now let us read the question. What they gave. A ray PQ is incident normally on the refracting surface BA is refracted in the prism BAC made of material 1.5, refractive index 1.5. Complete path of ray through the prism. From which phase will the ray emerge? Justify your answer. What is happening is here you see this figure also they gave in the question. One light ray is incidenting along the normally on the prism ABC. Okay, and then through which phase that light ray will emerge, that is we require. Now here in the diagram we see this is the incident light ray. Take this as incident light ray is incidenting like this. Along the normal it is incidenting. It is incidenting along the normal. Now here it is incidenting like this. When it is incident like this is only normal and this is only incident light ray. This is PQ. Then angle of incidence will become 0. When angle of incidence is 0, automatically angle of refraction becomes 0. And if you draw the normal at the second surface, here we draw the normal. This is the normal drawn at the second surface. This is the normal drawn at the second surface. And this angle will become again, what happens to that angle? This angle is R2. And now if R2 is the angle of incidence at here, okay, you see this angle is R2. That is incidenting it here, I1 is 0, R1 is 0. Here at the second surface R2 is C. Okay, if R2 is equal to, R2 value how much? We have to know. And if R2 is greater than critical angle, then it undergoes reflection. After the reflection, it may pass us through BC. And if it is goes refraction, then it will pass us through AC. Now the question with through which phase it will emerge, means whether the light ray undergoes total internal reflection at AC or not, that we require to know. Then for the purpose what we have to find out, the critical angle at here. Here angle of R2 value how much? Then from figure we write here some values. What we write from figure? We write I1 is 0 and R1 is 0 we write because normal incidence. Why we write this? Because normal incidence. And R1 plus R2 we know one formula, that is A. We substitute here R1 is 0 plus R2 is equal to A. From that we will get R2 value as 30 degree. A value we know already 30. Then after that I want to find out the refractive index of critical angle of prism. For that we know refractive index critical angle relation, that is refractive index formula nu is equal to 1 by sin c, that we know. Then from this if you find out the sin c value, sin c value we will get is 1 by nu. Then 1 by nu value is what? 1.5 in the question they give. This is nothing but 10 by 15. It is we can cancel this 5 3 ja 2 ja, and 2 by 3 we will get 0. We will get 3 6 ja 18, 0.66 we will get. And here condition for total internal reflection, whether total internal reflection occurs or not we check. Condition for total internal reflection, what is the condition? That is at the second surface, you see, at the second surface, first PQ blue light ray PQ is incident on AB surface. It is normally incidenting, that's why it will go in straight, and it will next it is incidenting on AC surface. Now it is trying to move away from the prism, and here R2 if it is greater than C, here angle of incidence is R2. Okay, if you draw the normal to the AC surface, angle of incidence is R2. If R2 is greater than critical angle, then total internal reflection takes place. Then the light passes through BC. If R2, that condition is not obeyed, then the refraction takes place. Then it will pass us through AC surface. You see, we write the condition, that is R2 greater than C. Then the total internal reflection occurs. Sin R2 greater than sin C. Then sin R2 value is what? You know R2 value, that is sin 30 greater than sin C. What is sin C value? You know already sin C value. Then here we will get a sin 30 value is 1 by 2, that is 0.5, and that is greater than sin C. What is the sin C value? Sin C value we got previously, that is 0.66. This condition is not obeyed, right? That means that is wrong. Total internal reflection not occurs, right? We write like this. That is in this case, therefore total internal reflection not occurs. Light ray passes through AC surface. If total internal reflection occurs, it passes through BC surface, but now it is passes through AC surface because the total internal reflection condition is not obeyed. That's why total internal reflection not occurs. If total internal reflection occurs, light passes through BC, but total internal reflection not occur, that's why it will pass us through AC. Okay, one homework problem I am giving, that is a ray of light. You see here the homework problem. A ray of light passing through an equilateral prism. A ray of light passing through an equilateral triangular glass prism from air undergoes minimum deviation. When angle of incidence is 3 by 4th of angle of prism, calculate the speed of light in prism. This is our question. Okay, you solve it. If you have any doubt, you can ask me. Till now, if you not subscribe my channel, subscribe and share to your friends. Ask to press the bell icon also to get the notifications and updates. Thank you.